Welcome. Today, let us take few next few problems of this question paper CBSE class 12 2019. Uh, our first problem is question number 14. Problem is solve tan inverse 4x plus tan inverse 6x is equal to pi by 4. So they together tan inverse 4x plus tan inverse 6x is equal to tan inverse pi by 4. That is tan inverse 10x by 1 minus 24x square is equal to pi by 4 gives 10x by 1 minus 24x square is equal to 10 pi by 4 is equal to 1. Now it becomes an algebraic equation, and using this we get 10x is equal to 1 minus 24x square, that is 24x square. It is taken into that side plus 10x minus 1 is equal to 0. To factorize, it is make it 12 minus 2. So 24x square plus 12x minus 2x minus 1 is equal to 0, giving 12x into 2x plus 1 minus 1 into 2x plus 1 is equal to 0. That is 2x plus 1 into 12x minus 1 is equal to 0. It means our required x is equal to, either this is equal to 0 means x is equal to minus half, and if this is equal to 0, x is equal to 1 by 12. Yes, that's all. So this is about the first problem, problem number 14. Next, next one is problem number 15. Use properties of determinant. Once again, use properties of determinant so that a square plus 2a plus 1, 3. Second column, 2a plus 1, a plus 2, 3. 1, 1 and 1. This is equal to a minus 1 whole cube. So we have to prove that, but we have to prove it using properties of determinant. Now let us start from left hand side. Operating C1 minus C2 and C2 and R2 minus R3, left hand side is equal to, so we have to operate first R1 minus R2, this minus that, so that it is equal to this minus that is a square minus 1. This become this minus that, a minus 1. This minus that is 0. Next, R2 minus R3, this minus that, so that 2a minus 2, this minus that, a minus 1, and this minus that is 0. And third row intact, 1. Now we can take a minus 1 common from first row. From here also, from second row, we can take a minus 1 common. So we get a minus 1, two factors from this and that. So a minus 1 whole square into a plus 1, 1, 0. It is 2, 1, 0 and 3, 3, 1. Now once again operating R1 minus R2. This become a minus 1 whole square into this minus that is a minus 1, 0, 0, and all other intact. 2, 1, 0, 3, 3, 1. Once again, we can take a minus 1 common from first row. So this is equal to a minus 1 whole cube into 1, 0, 0, 2, 1, 0, 3, 3, 1. Now this determinant now become a triangular determinant. All elements of elements above diagonal element is all are 0. So its value of the determinant is product of the three diagonal elements, so that it is equal to a minus 1 whole cube into 1 into 1 into 1, that is 1 whole cube. Yes, we get the result. Next problem. Next problem is problem number 16. If log of x square plus y square is equal to 2 tan inverse y by x, so that dy dx is equal to x plus y by x minus y. So one function is given, this is equal to that, and we have to find dy dx is equal to such and such. First of all, differentiate both sides with respect to x. So this becomes log function. So its derivative is 1 upon x square plus y square into derivative of this with respect to x, that is 2x plus derivative of y square with respect to x is 2y into dy dx is equal to derivative of that 2 into, it is basically tan inverse function, so 1 upon 1 plus y by x whole square, and derivative of that, it is actually equal to dy dx into x minus y into derivative of x is 1 by 2 derivative of this into y into x into a minus y into derivative of x divided by x square. Now this is equal to 2 into 1 by 1 plus y square by x square into x dy dx minus y divided by x square. Now multiply this x square with that. It is equal to 2 into x dy dx minus y divided by x square plus y square. So ultimately we get this is equal to that. Now from these two sides, removing by cancelling the factors x square plus y square, we get 2 into x plus y dy dx. This cancels, is equal to 2 into x dy dx minus y. Now cancel 2. So nothing is there. Correct coefficient of dy dx, it become y minus x into dy dx, this and that. Oh, this minus that is equal to that is equal to minus of x plus y. That is dy dx is equal to, cancelling negative from this and that, we get x plus y by x minus y. So we get the result. Dy dx is equal to this, and actually this is our answer. Next problem. Next question is 16 or. And the problem is, if x to the power y minus y to the power x is equal to a to the power b, find dy dx. So actually we have to differentiate both sides with respect to x. But in left side, x to the power y is present in power, function of x or y is present, so directly it cannot be differentiated. Similarly, for this one also, same case, directly it is not possible to differentiate. For that purpose, let us take u is equal to x to the power y and v is equal to y to the power x. Therefore, relation become u minus v is equal to a to the power b. Mind that a to the power b, it is a perfect constant. It is. Now differentiate both sides with respect to x. Therefore, we get du dx minus dv dx is equal to 0. Power is constant, and in fact all are constant. Suppose this is our equation 1. Now first find du dx from there. Taking log of both sides, we get log u is equal to y log x. Now it is no problem to differentiate both sides. So now differentiate both sides with respect to x. So this become 1 upon u into du dx is equal to, this is product of two factors. First of all, it is dy dx into log x minus plus y into 1 by x. Hence, du dx is equal to u into that. U means x to the power y into log x dy dx plus y by x. To say, similarly, taking log on both sides of that, we get this. We get log v x log y. Now we can differentiate it directly easily. Now, differentiating both sides with respect to x, we get 1 by v into dv dx, 1 into log y plus x into 1 by y into dy dx. So we get dv dx is equal to v into that. V is nothing but that. So y to the power x into log y plus x by y dy dx. So of equation 1, we get both du dx is equal to that and dv dx. So writing values of, taking values of du dx and dv dx from 2 and 3, the result become, just 1 minute. Du dx is equal to dv dx. Du dx is our x to the power y into log x dy dx plus y by x minus dv dx is y to the power x into log y plus x by y du dy dx. So ultimately we get this is equal to 0. Now, just 1 minute. Now, from this collecting coefficient of dy dx, we get dy dx here is this x to the power y into log x into dy dx minus y to the power x into x by y, that multiplied by dy dx is equal to this one, y to the power x log y minus x to the power y, y by x. Let us check. It is actually x to the power y into log x, and this is y to the power x into x by y. dy okay, say. So dy dx become y to the power x log y minus x to the power y into y by x. Into y by x divided by this thing, x to the power y log x minus y to the power x into x by y. To some extent we can simplify it, this and that you can simplify, but you can keep it in like that. And I would request you to verify the all calculations in that problem. Please verify it. Acha, next problem now. Our next problem is if y is equal to, problem number 17, if y is equal to sine inverse x whole square, prove that 1 minus x square into d2y dx2 minus x into dy dx minus 2 is equal to 0. So given thing is this, and we have to prove it. Now differentiating the given with respect to x, we get dy dx is equal to 2 sine inverse x to the power 1, that is 2 minus 1, that is 1, into derivative of sine inverse x 1 by root over 1 minus x square. Now squaring both sides and cross multiplying. Squaring both sides and cross multiplying, we get 1 minus x square, this, into that dy dx whole square is equal to squaring, so we get 2 into sine inverse, 2 square sine inverse x whole square. 2 square is 4 into sine inverse x whole square. Now sine inverse x whole square is nothing but y, so it is 4y. Now once again differentiating both sides with respect to x. So it become derivative of that first I am writing. So 2 into dy dx to the power 1, 2 minus 1 is 1, into derivative of that d2y dx2 into first factor intact. Next, derivative of this into this intact. So minus 2x into dy dx whole square is equal to 4 into dy dx. Now in that type of problems, from both sides, 2 dy dx must cancel. 2 dy dx must cancel. Here is 2 dy dx. Here also 2 into dy dx whole square. Here also 2 into dy dx. So cancelling that, we get 1 minus x square into d2y dx2. This cancelled. Minus 2 cancel, 1 dy dx cancel. So x into dy dx is equal to 2. 2 into dy dx cancels, so only 2. So changing side, we get our result. 1 minus x squared d2y dx2 minus x dy dx minus 2 become 0. So, okay, the proof is complete. So let us stop today. Uh, next, in next few classes, we will start from next question, that is question number 18. Before that, I request you to like the video, share my video, and subscribe if not yet subscribed. Thank you.